Hello students, today we will be discussing atomic structure for grade 9 chemistry. Before we move on to actually atomic structure, let's think about everything that exists around us. A laptop, a table, a chair, or even something as small as a pencil or pen. They are all different kinds of matter, things that exist in this world. Have you ever wondered what all of these things, everything around us, including us, is made up of? What do we consist of? So, let's think about it a little deeper. Everything that is made in this world consists of or is made up of atoms. What was once considered the smallest particles to have existed have now been found of constituting of even further smaller particles. So what are you wondering are the further smaller particles forming the atom? The first one is a proton. A proton exists in the nucleus of an atom. It has a relative charge of +1 and is represented by the symbol P. The second subatomic particle is a neutron, which also exists in the nucleus along with the proton. It has a relative charge of 0 and is represented by the symbol N. The third is an electron, which actually rotates around the nucleus in energy shells known as orbits. Electrons are represented by the symbol E and have a relative charge of -1. While protons and neutrons have a relative mass of 1, electrons have an almost negligible mass of 1 upon 1840. Protons determine the atomic number as well as the element itself. What does that mean? Determining the element itself means, as discussed earlier, each element has a unique proton number or atomic number that represents it in the periodic table. So the proton number or the atomic number decides what element it forms. Neutrons, on the other hand, contribute to the mass of the atom as well as play a role in the formation of isotopes, which we will discuss later. Protons and neutrons together form the nucleus of an atom. Electrons, on the other hand, play a crucial role in the chemical bonding and reactivity. As discussed earlier, chemical bonding is of 3 types: ionic bonding, metallic bonding, and covalent bonding. We will be discussing these later in detail and what role electrons play in them. Each atom, is important to note, has the same number of protons and electrons, cancelling out the positive charges with the negative ones. As a result, all atoms are electrically neutral. These subatomic particles can be used to deduce other properties or details about an atom. Let's say you know the proton number, so you can use it to find the atomic number, also known as the proton number, represented by the letter Z. It represents the number of protons in the nucleus of an atom. It determines the element and its position in the periodic table. Since atoms are electrically neutral, the proton number can also be used to find out the number of electrons in an atom. Each atom always has the same number of protons and electrons. Therefore, if one knows the number of protons in an atom, it is safe to assume that it will have the same number of electrons. Each element has a unique proton number. This suggests that no other element has atoms with the same proton number. Which brings us to the nucleon number, represented by the symbol A. Nucleon number is also known as the mass number and is the sum of the protons and the neutrons in the nucleus of the atom. Therefore, a nucleon number can be represented by adding the number of protons and neutrons. Let's say you look up an element in the periodic table and you know the mass number or the nucleon number of that element, but you want to find out the number of neutrons. You can always subtract the proton number from this nucleon number to find out the number of neutrons. Let's see how the proton and nucleon numbers are represented in an element in a periodic table. Let's see, the letter X represents the chemical symbol of the element, how it would present itself in the periodic table. The letter A on the left of the symbol on the top left, it represents the nucleon or mass number in the superscript. The letter Z on the lower left side represents the proton or atomic number in subscript towards the left of the symbol. If one wants to find out the number of electrons present, one can safely assume that the number that represents Z is the same for the number of electrons. However, if you would like to find the number of neutrons present in that particular atom, you can always subtract Z or the proton number from the mass number or nucleon number, which is represented by the letter A.